Step 2 in the 5 steps of hypothesis testing is to create a null and alternative hypothesis. The null hypothesis states that there is no difference between the sample mean and the population mean, and by extension, any apparent differences are due to chance. Expressed in words, the null hypothesis would be the average weight of babies born in Siberia will be no different than the world average of 7.5 pounds. Expressed in numbers, we would write a null hypothesis as h sub 0 colon mu equals 7.5. And in some cases, we would write our null hypothesis as mu1 equals mu2. Both ways of writing the null hypothesis say the same thing. There's no difference between the means. What the null hypothesis is telling us is this: despite what it looks like, the two means look different, there is no real and meaningful difference between the sample mean and the population mean. Sure, they might differ a little, but those differences are due to random chance, so we should treat these means as though they are the same. The alternative hypothesis states that one group will be significantly different than the other. The sample mean and the population mean are truly different, so differences are real and due to a treatment effect. Expressed in words, the average weight of babies born in Siberia will be different than the world average of 7.5 pounds. Expressed in numbers, we would write h sub 1 colon mu does not equal 7.5. The null hypothesis is always written as h sub 0 colon. And typically the alternative hypothesis is written as h sub 1 colon. The alternative hypothesis may also be written as h sub a or h sub 2 if you have multiple alternatives, but the null is always h sub 0. So now I need to go back and clean up something that I was sloppy about when I first introduced you to the alternative hypothesis. I taught you about the alternative hypothesis that was non-directional, but I actually used directional examples. So let's unpack that and make sure that we're clear. Alternative hypotheses can be either directional or non-directional. Direction refers to the direction that the dependent variable changes. Will it increase or decrease? With a directional alternative hypothesis, you say that the sample mean will be higher than the population mean. Or in another case, you might say the sample mean will be lower than the population mean. For our example, we could create a directional alternative hypothesis that our Siberian sample mean will be higher than the world population mean. And this would be called a one-tail test. More specifically, a one-tail test right because we are only interested in significant changes greater than the mean. We could construct a one-tail test left alternative hypothesis if we were only interested in sample means lower than the population mean. Expressed in numbers, we use the greater than and less than signs to indicate direction of change. So for example, h sub 1 colon mu is greater than 7.5. And this means the average weight of babies born in Siberia will be higher than the world average of 7.5 pounds. Both of these are called a one-tail test because you're interested only in one direction of change. One tail can only go in one direction at a time. An alternative hypothesis can also be non-directional. With a non-directional alternative hypothesis, we simply state that the sample mean will be different than the population mean, but we do not say whether it will be higher or lower. We could write a non-directional alternative hypothesis as h sub 1 colon mu does not equal 7.5, meaning the average weight of babies born in Siberia will be different than the world average of 7.5 pounds. This type of hypothesis uses a two-tailed test because we are considering change in either direction. 2 tails means 2 directions. For our baby weight example, step 2 would be null hypothesis, mu equals 7.5. The average weight of babies born in Siberia will be no different than the world average of 7.5 pounds. The alternative hypothesis, H sub 1, mu does not equal 7.5. The average weight of babies born in Siberia will be different than the world average of 7.5 pounds.